Imagine discovering that almost everything in the universe is invisible. Not hidden behind clouds or lost in distant galaxies, but fundamentally invisible to every telescope humanity has ever built. The stars, planets, nebulae, and galaxies that fill the night sky, everything we can see, make up only a tiny fraction of reality. In fact, scientists now believe that nearly 95% of the universe is made of something we cannot see, cannot touch, and barely understand. It surrounds us, shapes galaxies, and controls the fate of the cosmos. And yet, even with the most advanced technology ever created, humanity still has no clear explanation for what it truly is. This is the story of the greatest mysteries of the universe, secrets that science still cannot explain. For centuries, humans have looked toward the night sky with wonder. Ancient civilizations believed the stars were divine fires placed in the heavens by gods. Philosophers imagined cosmic spheres moving in perfect harmony, but today, armed with powerful telescopes, particle accelerators, and space observatories orbiting the Earth, scientists have discovered something both extraordinary and unsettling. The deeper we look into the universe, the more mysteries we uncover. Modern science has revealed breathtaking truths about the cosmos, the age of the universe, the birth and death of stars, the formation of galaxies, and the strange physics governing space and time. Yet for every question we answer, several new questions appear. In many ways, humanity has reached a remarkable moment in history. We know more about the universe than any generation before us, yet we are also becoming increasingly aware of how little we truly understand. The universe is not just vast, it is deeply mysterious. And some of its most fundamental secrets remain unsolved. One of the most astonishing mysteries is something called dark matter. In the early 20th century, astronomers began studying the movement of stars within galaxies. According to the laws of physics, the gravity created by visible matter, stars, planets, and gas, should determine how fast these stars move. But when scientists carefully measured the speeds of stars orbiting galaxies, they found something strange. The stars were moving far too fast. According to the amount of visible matter present, galaxies should not have enough gravity to hold themselves together. Yet they do. Something invisible seems to be providing extra gravitational pull, preventing galaxies from flying apart. This mysterious substance became known as dark matter. Scientists believe dark matter may make up about 27% of the entire universe. It does not emit light, reflect light, or interact with electromagnetic radiation in any way we can detect. It is completely invisible. Yet its gravitational effects can be seen everywhere, from the rotation of galaxies to the large-scale structure of the cosmos. Over the decades, physicists have proposed many theories about what dark matter might be. Some suggest it consists of undiscovered particles that rarely interact with ordinary matter. Others believe it could involve entirely new forms of physics beyond the standard model of particle physics. Massive underground detectors, deep beneath mountains and laboratories, are constantly searching for signs of dark matter particles. But so far, despite decades of effort, dark matter remains one of the greatest unsolved puzzles in science. Even more mysterious is something scientists call dark energy. In the late 1990s, astronomers studying distant exploding stars known as supernovae made a shocking discovery. They expected to find that the expansion of the universe, triggered by the Big Bang billions of years ago, was gradually slowing down due to gravity. Instead, they discovered the opposite. The universe is not slowing down. It is accelerating. Galaxies are moving away from each other faster and faster as time passes. Something appears to be pushing the universe apart, counteracting the pull of gravity on cosmic scales. Scientists call this unknown force dark energy. Today, dark energy is believed to make up about 68% of the entire universe. It is the dominant component of cosmic reality. Yet its nature remains completely unknown. Some theories suggest dark energy might be related to the energy of empty space itself, a property predicted by quantum physics. Others propose that gravity behaves differently across vast distances, requiring a new understanding of the laws of physics. There are even theories suggesting that dark energy may change over time, influencing the ultimate fate of the universe. If dark energy continues to accelerate expansion indefinitely, galaxies may drift so far apart that the universe becomes cold, dark, and empty. This scenario is sometimes called the Big Freeze. But until scientists understand what dark energy truly is, the future of the cosmos remains uncertain. Another mystery lies at the very beginning of everything, the origin of the universe itself. According to current scientific understanding, the universe began approximately 13.8 billion years ago in an event known as the Big Bang. In an unimaginably hot and dense state, space and time themselves came into existence. Within fractions of a second, the universe expanded rapidly, cooling as particles formed, atoms emerged, and eventually stars and galaxies appeared. The Big Bang theory is supported by strong evidence, including the cosmic microwave background radiation, the faint afterglow of the early universe, and the observed expansion of space. But one profound question remains unanswered: what caused the Big Bang? What existed before it? Did time itself begin in that moment, or was there some earlier cosmic reality that triggered the birth of our universe? Some physicists suggest that our universe may have emerged from a quantum fluctuation in a vacuum, a tiny burst of energy that suddenly expanded. Others propose that the Big Bang was not the beginning at all, but part of an endless cycle of universes expanding and collapsing over time. There are even theories suggesting that our universe may have emerged from a higher dimensional space, or that it is one of many universes within a vast cosmic multiverse. At present, these ideas remain speculative. The true origin of the universe may be one of the deepest mysteries humanity will ever confront. Among the most fascinating and extreme objects in the universe are black holes. These cosmic monsters form when massive stars collapse under their own gravity. The collapse becomes so intense that space and time themselves are warped into an infinitely dense point called a singularity. Surrounding the singularity is the event horizon, a boundary beyond which nothing, not even light, can escape. For decades, black holes were considered purely theoretical. But today we know they are real. Astronomers have observed stars orbiting invisible massive objects at the centers of galaxies. Gravitational waves detected by observatories on Earth have confirmed the collisions of black holes billions of light-years away. In 2019, scientists even captured the first image of a black hole's shadow using a global network of telescopes known as the Event Horizon Telescope. Yet black holes remain deeply mysterious. At the center of every black hole lies a singularity where the known laws of physics break down. Einstein's theory of general relativity predicts infinite density, while quantum mechanics suggests something entirely different. Physicists believe a new theory, often called quantum gravity, will be required to understand what truly happens inside a black hole. Some theories even suggest black holes could be gateways to other regions of space, or possibly even other universes. The idea of a multiverse takes cosmic mystery even further. According to some modern theories of physics, our universe might not be the only one that exists. Instead, it could be just one bubble within a vast cosmic ocean containing countless universes. Each universe might have different physical laws, different constants of nature, and entirely different histories. Some universes might contain no stars at all. Others might have entirely different forms of matter and energy. The concept of the multiverse emerges naturally from several theories, including cosmic inflation and certain interpretations of quantum mechanics. Inflation theory suggests that shortly after the Big Bang, the universe expanded extremely rapidly. Some physicists believe this process could create multiple universes in different regions of space. Meanwhile, quantum theory suggests that every possible outcome of certain events may actually occur in separate realities. While the multiverse remains hypothetical, it raises profound philosophical questions about reality itself. If countless universes exist, then our universe might simply be one of many cosmic possibilities. Another strange mystery lies hidden behind our own galaxy. Deep in space, in the direction of the Centaurus and Norma clusters of galaxies, astronomers have detected a gravitational phenomenon known as the Great Attractor. Thousands of galaxies, including our own Milky Way, appear to be slowly drifting toward this mysterious region. Something enormous is exerting a powerful gravitational pull across hundreds of millions of light-years. Yet observing the Great Attractor directly has proven extremely difficult because it lies behind a dense region of stars and dust in our own galaxy known as the zone of avoidance. Scientists believe the Great Attractor may be part of a massive supercluster of galaxies, perhaps linked to an even larger structure called the Laniakea supercluster. But the full nature of this gravitational force remains uncertain. It is as if an invisible cosmic current is slowly pulling entire galaxies across the universe. Occasionally, astronomers detect extremely powerful flashes of radio waves from deep space. These events are known as fast radio bursts. Each burst lasts only a few milliseconds, yet during that tiny fraction of time, it can release as much energy as the sun emits over several days. The first fast radio burst was discovered in 2007, and since then hundreds have been detected. Some bursts occur only once and never repeat, while others seem to come from repeating sources. Scientists believe these signals may originate from extremely energetic objects such as magnetars, neutron stars with incredibly strong magnetic fields. But the exact cause of many fast radio bursts remains uncertain. Their mysterious nature has even sparked speculation about advanced extraterrestrial technologies, although no evidence currently supports such claims. Still, these signals remind us that the universe is filled with phenomena we are only beginning to understand. One of the most profound mysteries of all may not lie in distant galaxies, but within ourselves. Consciousness, the awareness of our own existence, remains one of science's greatest puzzles. The human brain is composed of billions of neurons communicating through electrical and chemical signals. Yet how these physical processes produce subjective experiences, the sensation of seeing colors, feeling emotions, or contemplating the universe, remains deeply mysterious. Some scientists believe consciousness emerges naturally from complex neural networks. Others suggest it may involve deeper principles of physics that we do not yet understand. There are even theories proposing that consciousness might be a fundamental aspect of the universe itself, much like space, time, or energy. If true, this would mean that the mystery of consciousness is not only a biological question but a cosmic one. Another fascinating question concerns the possibility of intelligent life beyond Earth. The universe contains hundreds of billions of galaxies, each with billions of stars. Many of those stars host planets. Statistically, it seems almost certain that life should exist elsewhere. Yet despite decades of searching, humanity has found no clear evidence of extraterrestrial civilizations. This mystery is known as the Fermi paradox. If intelligent life is common in the universe, then where is everybody? Some scientists suggest that intelligent civilizations may be extremely rare. Others believe that technological societies might destroy themselves before they develop interstellar communication. It is also possible that alien civilizations exist but communicate in ways we cannot detect. Or perhaps they are so far away that their signals have not yet reached us. The Fermi paradox remains one of the most intriguing questions about our place in the cosmos.